All right, let's dive right in. Welcome to this explainer. Today we're unpacking AWS edge and hybrid patterns, and honestly, it's a pretty fascinating architectural journey. We're going to start way out wide, looking at the massive global expanse of the cloud, and then we're zooming all the way down into the literal, physical spaces where business actually happens. So if you've ever wondered how modern apps get that snappy, instant response feel, you are in the exact right place. It's a super frustrating reality, isn't it? If the cloud is supposedly everywhere, why on earth is your data still lagging? We've all been there. You click a button and you wait. The video buffers, the app stutters. The cloud is massively powerful, sure, but there's a reason we still get that irritating delay. It's a puzzle that some of the brightest minds in tech are actively trying to solve. So here's our roadmap for today. We'll cover battling the speed of light, navigating the global edge, the power of local zones, hardware on the factory floor, the hidden trade-offs, and finally, is the edge worth it? Starting off with Section 1, battling the speed of light. Let's just strip away all the software jargon for a second and get back to pure physics. The absolute ultimate constraint of cloud computing is the speed of light. Data, whether it's an email or a massive database query, is physical. It's pulses of light in fiber optic cables or electrical signals on a wire. And it actually takes physical time for that data to travel from a massive data center in, say, Virginia, all the way to a user's smartphone in Tokyo. It's exactly like a commute. If your office is hundreds of miles away, it really doesn't matter how fast you run out your front door. The journey itself is just going to take time. Which brings us to latency. Basically, latency is the delay before a data transfer even begins following an instruction. It's the time your data spends commuting. Now, if we want to reduce latency and make our apps faster, well, we can't break the laws of physics, right? We can't make the speed of light go any faster. So the alternative? We have to move the processing plant closer to the user. Just like moving closer to your office saves you time and fuel on your daily commute, moving data and compute power closer to the end user dramatically cuts down on that lag. All right, Section 2, navigating the global edge. So how do we handle content that doesn't change very often? Enter AWS CloudFront. Think of CloudFront as a global network of digital distribution centers. Instead of making every single user fetch a popular video clip or image from a centralized server halfway across the world, CloudFront caches or stores a copy of that static content at the edge, much closer to the users. It's exactly like a supermarket keeping its most popular items fully stocked on the shelves right around the corner, rather than making you drive to the main warehouse every single time you need a loaf of bread. But wait, what if your data isn't static? What if it's a live multiplayer game or a real-time financial trading app? You obviously can't cache a live, unpredictable interaction. That is where AWS Global Accelerator comes in. It's a networking service that finds the absolute fastest, most optimal path for dynamic traffic. Instead of your data bouncing around the public internet with all its random traffic jams and unpredictable detours, Global Accelerator puts your data onto the dedicated, high-speed AWS global network immediately. It is literally the high-speed toll lane for your real-time data. So, to lay it out clearly, CloudFront caches static content at the edge, near the users. Global Accelerator, on the flip side, finds the fastest network path for dynamic, real-time traffic. They're both global edge solutions, but they serve completely different types of traffic. As an architect, knowing this difference means you know exactly which tool to pull from your AWS toolbox to solve your specific problem. Moving on to Section 3, the power of local zones. So what happens when a global cache just isn't close enough? Let's say you're running a massive multiplayer gaming hub, or maybe a live video production studio right in the heart of Los Angeles. Even with a global edge network, routing your heavy, complex compute tasks back to a standard AWS region hundreds of miles away, that might still introduce way too much lag for that specific, highly demanding metropolitan audience. The edge actually needs to get even closer. And this is where AWS local zones completely change the game. We're talking about deployments of core compute and storage services directly into specific metropolitan areas. We aren't just caching static images anymore. We are physically putting heavy-duty processing power and storage, the real brains of the operation, right into major cities. By doing this, local zones deliver single-digit millisecond latency. It allows companies to run their most intense, latency-sensitive apps right in their users' backyards. It's like bringing the heavy machinery straight to the local neighborhood. Next up, Section 4, hardware on the factory floor. Because sometimes your data absolutely cannot leave the building. Picture a massive automated industrial site. You've got this highly advanced robotic arm assembling precision machinery. That arm relies on real-time data processing to make micro-adjustments every single millisecond. If the system processing that data is even a few miles away in a local zone, that round-trip delay could cause the arm to miscalculate, ruining the product or even causing a major safety hazard. For scenarios like this, a distant cloud, even a regional one, just can't provide the instant reflexes you need. The solution here is AWS Outposts. And I actually want to slow down for a second because this is a wild concept if you're used to the cloud being just this invisible entity in the sky. AWS Outposts are literal, physical AWS hardware racks. They are delivered and installed directly on your physical premises, in your factory, your hospital, your own data center. But, and here's the magic part, they're managed seamlessly by the cloud, using the exact same APIs and control planes you use for the rest of AWS. You get the ultra-low latency of having the server sitting literally right next to the robotic arm, combined with the absolute ease of cloud management. Section 5. The hidden trade-offs. Now, it's super easy to get swept up in the excitement of single-digit millisecond latency and seamless hybrid hardware. Moving processing to the edge sounds absolutely incredible, and honestly, it is. But what's the hidden catch? Edge computing isn't just magic pixie dust you sprinkle on a slow app to make it fast. It's a massive architectural shift, and it requires some very serious consideration before you dive in headfirst. When we look at centralized cloud versus edge architecture, we see three huge trade-offs. First, cost. Centralized cloud benefits from massive economies of scale. When you start pushing physical hardware and services out to the edge, especially stuff like Outposts, your costs are absolutely going to go up. Second, management burden. A centralized system is generally much easier to secure and update. Distributing your application across global nodes, local zones, and physical factory floors, that inevitably increases the burden on your ops team. And third, architectural complexity. Building a system that flawlessly syncs data between the deep cloud and the extreme edge requires incredibly sophisticated engineering. Ultimately, you are taking on complexity to buy speed. Finally, Section 6. Is the edge worth it? Let's build a clear framework here. You know what tools are out there and you know the trade-offs. So how do you actually decide when these edge services make sense for your specific business? Let's walk through a quick step-by-step tool you can use to evaluate your own infrastructure. Step 1. Assess strict latency needs. Does your app genuinely require single-digit millisecond response times to function safely or effectively? If a 1-second delay is perfectly fine, you probably don't need the edge. Step 2. Evaluate budget constraints. Are you actually prepared to take on the higher operational and physical costs of a decentralized architecture? And step 3. Check local data residency rules. This is a big one. Sometimes the edge isn't about speed at all, it's about the law. If local government regulations dictate that your data cannot physically leave the country or region, tools like local zones and outposts become incredibly valuable for maintaining compliance while still utilizing cloud services. I want to leave you with this final, somewhat provocative thought. As we push the cloud out of massive central data centers and back onto our own factory floors and into our local offices with tools like Outposts, are we basically just reinventing the traditional on-premise server room? It is such a fascinating cycle of technological infrastructure to ponder. The pendulum swings from localized to centralized, and now dynamically right back to the edge. Thanks so much for joining me for this explainer, and I really hope this helped clarify the incredible world of AWS low latency and hybrid patterns.